The research paper presents an approach to Hod Pair Capturing, HPC, a significant open problem in descriptive intermodal theory. It introduces two principles, direct limit independence and bounded direct limits, which imply HPC. The authors discuss the importance of descriptive intermodal theory, focusing on the core model induction and the conjecture 0.2 related to the proper forcing axiom and intermodals with subcompact cardinals. They highlight the Hod problem and its connection to HPC. The paper also discusses the relevance of HPC to set theoretic complexity and its connection to the core model theory. The authors introduce the concept of a generic generator, which is a key concept in this paper. They define the notion of a Hod pair generated model and introduce the connection between generic generators and the iterability conjecture for KC-MISH. The paper concludes by stating the main basic theorem about increment VGEN, HP, assuming AD plus and showing that if increment gen, HP does not equal R, then theta reg is the theory AD plus, theta is a regular cardinal. The paper explores the concept of generic generators in the context of intermodal theory, focusing on their relationship with the derived model of a background universe and the reals in that universe. A generic generator is defined as a pair, P, sigma, where P is an omega sequence of iterates of a background universe and sigma acts on L, P. The main theorem states that if M is not generated, then there exists a generic generator for M. To prove this theorem, the authors use a sequence of iterates, M alpha, pa, beta, alpha less than omega, of a minimal sound mouse M with a Wood-in cardinal that is a limit of Wood-in cardinals. They show that P, lambda, is a generic generator for M, where P is the direct limit of the sequence and lambda is the direct limit of the corresponding sequence of strategies. The paper also discusses the production of generic generators using fully backgrounded constructions of sufficiently strong backgrounds. It assumes the existence of the minimal active mouse with a Wood-in cardinal that is a limit of Wood-in cardinals, denoted as M. The authors define a Suslin, co-Suslin capturing background universe V and set delta equals delta VGEN. They assume ADR and not HPC, which implies that there are good point classes beyond delta. The authors outline the main strategy for establishing HPC and other statements like it, involving showing that the Hod pair construction of M reaches a Hod pair beyond delta. However, previous works assume stronger assumptions than NLE, such as no Hod mouse with an inaccessible limit of Wood-ins and no transitive inner model of LSA. The paper aims to establish HPC and other statements using weaker assumptions. In the following sections, the authors delve into the concept of fully backgrounded constructions and present several lemmas and corollaries related to generic generators. They also discuss the main theorem of this section, Theorem 3.5, which states that if V satisfies ADR plus NLE plus not LEC, then there is a pagan-Eric generator for delta gen, P in V, G, where G subset equal call, omega, R, is V generic. Similarly, if V satisfies ADR plus NLE plus not HPC, then there is an HP generic generator for delta gen, HP in V, G. The proof of this theorem involves constructing an omega sequence of iterates of M, where M is a psi mouse over X, and using corollary 3.2 to show that the strong cardinals of M are preserved in the iterates. The paper presents a construction of a generic generator, focusing on the development of a class-size psi mouse with a Wood-in cardinal. The construction involves models P-Xi and R-Xi, starting with P0 as M alpha, kappa plus alpha, M alpha, and iteratively adding backgrounded extenders from W-Xi, and branches from W-Xi. The process is shown to last delta Y many steps, and a lemma demonstrates the well-definedness of the construction. In the context of set theory, particularly intermodal theory, the concept of generic generators and their relationship with Wood-in cardinals is explored. A generic generator is a pair, P, sigma, where P is a transitive model of ZFC power set and sigma is a strategy for P. The main result, Theorem 3.5, states that under certain conditions, there exists a pagan-Eric generator, P, sigma, such that sup, W, P, union sulfur monophosphide, less than omega 1 and all strong cardinals of P are limits of Wood-in cardinals. To prove this theorem, the authors use a fully backgrounded peg-producing iteration of a given mouse pair, n asterisk operator x0, delta x0, sigma x0. This construction involves defining a sequence of mice, m alpha, ka, j alpha, beta. Alpha is less than or equal to omega 1, and a sequence of strategies, saw. Alpha is less than or equal to omega 1, for these mice. The construction ensures that the final mouse m omega 1 has the desired properties. The paper also discusses amenable linear iterations and introduces a definition for amenability in the context of premise. An extender E is said to be amenable to a model M if for any x in M and a element of LH E less than omega A intersection X element of M. Furthermore, the authors mention the possibility of using Hod pair constructions instead of L opening square bracket E constructions to produce a HP generic generator, and resolve a gap in the literature regarding the Wood-in cardinality of delta x0 in the Hod pair construction of n asterisk operator x0. Here is a combined summary of the 4 pages. The paper explores the properties of generic generators, focusing on the relationship between models and extenders. It introduces amenable linear iterations and their connection to iteration trees, whose main branch is used to construct models and extenders, ensuring critical points are below the image of an inaccessible cardinal. This setup is crucial for proving corollary 4.3, which states that if 2 premise models share the same largest cardinal and have the same properties regarding ZFC and the cardinal's inaccessibility, they are equal. The corollary is established by showing that one model is contained within the other and then using the equality of their last models. The paper also discusses the direct limit independence hypothesis, which involves the independence of certain models from specific parameter sets. This is done by defining the direct limit of a set of models and extenders and then stating the hypothesis in terms of generic generators and their properties. The direct limit independence hypothesis is then applied to compute the power set operation in generic generators. It is shown that if there is a non-generated set of reals, the L opening square bracket E construction of an n asterisk operator X model reaches a Wood-in cardinal that is a limit of Wood-in cardinals. This result also carries over to Hod pair generic generators, assuming one can resolve the issue raised in remark 3.13. Furthermore, the paper defines a weak cut point of P and provides a definition of P, eta plus, P from P, eta, where eta is a weak cut point of P. The computation shows that P, eta plus, P is simple and yields a contradiction when we also assume that P, sigma, is backgrounded. The theorem assumes V semantically entails ADR plus NLE plus V equals L, R, and proves that under certain conditions, P, eta plus, P is contained in ODVP, eta, X. The result is significant in the context of generic generators and the study of Wood-in cardinals. Here is a combined summary of pages 17-20. The research paper explores the properties of generic generators and their relation to Wood-in cardinals, concluding that P0 equals Q0 based on the generator's properties and their extenders. This leads to the notion of a Wood-in cardinal as a limit of Wood-in cardinals. Assuming DLIH and boundedness of Wood-in cardinals, the paper shows that there exists a mouse with a Wood-in cardinal that is a limit of Wood-in cardinals, using a peg-producing iteration and a strategy sigma to induce a self-justifying system. The computation of power sets and the existence of superstrong extenders are also discussed. The paper then introduces the concept of bounded direct limits and shows how they can be used to prove LEC assuming NLE. The importance of Wood-in cardinals and their properties in understanding the structure of the universe is emphasized. Theorem 6.3 assumes that V models ADR plus NLE plus V equals L, R, plus not LEC, and for every A subset equal R, there exists an ALF background. The proof involves a contradiction, assuming that V models both DLI, increment, and BDL, increment. A set of subset equal R is chosen such that gamma less than theta L, A, R, increment subset equals sigma 21, A, tilde operator L, A, R, and A is Waj above all sets in increment. In V, G, the union H of all M infinity, P, sigma, where P, sigma, is a Pagan-Eric generator for increment is considered, and it is shown that H element of V and H element of L, A, R. The concept of almost a full and a full sigma subset equal R is introduced, and it is proven that the set of almost a full sigma contains a club in V, G. Embeddings J sigma and J plus are defined, and sets B and C of reals are introduced to code a full sigma and sigma subset equal tau, respectively. A universal gamma set D subset equal omega times R is defined, and claim 6.4 proves that if kappa is an inaccessible cardinal of Vp delta, then for any p generic H subset equal call omega less than kappa, sigma H is a full. Claims 6.5 and 6.6 are used to show that K has a superstrong extender, and finally, nu intersection M plus is defined in R tau from K sigma, tau upwards harpoon barb rightwards M and J sigma, tau M, showing that nu intersection M plus is ordinal definable from a intersection tau, x0, and sigma. The paper delves into the ordinal definability of the set nu intersection M plus from a intersection sigma, x0, and sigma, leveraging the fact that C is in delta tilde gamma and x1 is chosen such that nu intersection M plus element of C gamma, sigma. This result is pivotal in the proof of theorem 6.3, which can be extended to Hod pairs assuming not HPC. The authors then shift their focus to justifying the plausibility of DLI and BDL. They introduce the concepts of PBAD and HPBAD, which relate to the L opening square bracket E, construction of NX and the point class gamma. Conjecture 7.3 posits that if F is projective, then it is neither PBAD nor HPBAD, assuming AD+. The authors provide evidence for this conjecture by showing that HPC implies conjecture 7.3 for many projective F. Conjecture 7.4 is then presented, which states that for every set B subset equal R, there exists F such that F is not PBAD and B element of delta tilde base, F. The authors prove that assuming NWLW, they can establish a comparison theorem for generic generators, which implies DLI, delta, and BDL, delta. However, they note that to prove conjecture 7.4, they need to establish a comparison theorem for generic generators without assuming NWLW. The authors conclude by remarking that to prove LEC or HPC, it is sufficient to establish conjecture 7.3 and conjecture 7.5, which deals with the existence of a common iterate of two generic generators. Finally, they provide a list of references that support their research. In the subsequent section, the paper discusses the concept of generic generators, a crucial element in the study of inner model theory. It begins by referencing Steele's work on derived models associated with mice, which is a fundamental concept in the field of computational prospects of infinity. Steele's research provides an in-depth analysis of these models, outlining their structure and properties. The paper then delves into the derived model theorem, a key result in Logic Colloquium 2006. This theorem establishes a connection between the generic extension of a given model and its derived model, shedding light on the relationship between these two important concepts in set theory. Steele's outline of inner model theory is also referenced, providing a comprehensive overview of the subject. This work offers insights into the structure and properties of inner models, which are essential for understanding the hierarchy of sets in ZFC, Zermelo-Frankel choice, axiomatic set theory. Furthermore, the paper touches upon mouse pairs and Suslin cardinals, a topic explored in Steele's 2022 publication. Mouse pairs are a critical component in the study of inner models, as they help to establish connections between different levels of the set theoretic universe. Suslin cardinals, on the other hand, are a class of large cardinals that play a significant role in determining the consistency of various set theoretic statements. Finally, the paper references Steele's comparison process for mouse pairs, a recent work that aims to compare and contrast different mouse pairs. This research is vital for advancing our understanding of the relationships between various inner models and their implications for set theory. In conclusion, the paper provides a detailed exploration of generic generators, derived models, and inner model theory, highlighting the importance of these concepts in the study of set theory and large cardinals. The work referenced by Steele offers valuable insights into the structure and properties of these models, contributing significantly to the ongoing research in this field.